Properties of exponents. In this video, we will use the definition of exponents to discover important properties of exponents, and then we're going to use those properties to simplify expressions.
An exponent represents repeated multiplication. So the exponent n represents how many copies of the base x are multiplied together. If n is 2, we have 2 copies of x. X times x. This is read x to the second power, or x squared. If n is 3, we have x to the third power. 3 copies of x are multiplied together. And that's also called x cubed. We can even have n equal 1. X to the 1 power is 1 copy of x. Although x can be any real number, the exponent, according to this definition, has to be a counting number to count the number of copies. Later, we're going to be able to expand the definition to use other numbers besides counting numbers for exponents. If I'd like to add or subtract terms with exponents, if the exponents are different, I can't really simplify further. That's because these are not like terms. On the other hand, if I want to multiply with the same variable but different exponents, I can certainly do that. X squared means 2 copies of x are multiplied together, and x cubed means that 3 copies of x are multiplied together, and so altogether I have 5 copies of x multiplied together. 2 here and 3 here. So 2 plus 3 is what gives us the number of copies of x. That gives us a property of exponents called the multiplication rule. If we multiply 2 exponential expressions with the same base, the product has an exponent that's the sum of the 2 exponents. Well, we've discovered a multiplication property. Let's see if we can discover a division property. If I have an expression like x fifth divided by x squared, I'm going to write 5 copies of x multiplied on top and 2 copies of x multiplied on the bottom. When I cancel, the 2 on the bottom take away 2 on the top. And so there's 3 left on the top. The result is x third. The 3 came from the 5 copies minus the 2 copies that cancel. So a rule for division can be written x to the n divided by x to the m is x to the n minus m. Now this is kind of cool because when we multiply, we add the exponents. When we divide, we subtract the exponents. Multiplication and division are opposites, and so are addition and subtraction. So this rule makes a lot of sense. Well, so far we've discovered 2 properties. This time let's work on what happens if an exponent is applied to something in parentheses. Well, if the things in parentheses are added, 3 plus 4 is 7, and 7 squared is 49. But 3 squared plus 4 squared is not 49. 9 plus 16 is 25. So exponents outside the parentheses don't distribute over addition. On the other hand, if we have a multiplication in the parentheses, 3 times 4 squared is 12 squared, 144. And 3 squared times 4 squared is 9 times 16. and that's also 144. Exponents outside the parentheses do distribute over multiplication. We can write this property as the product of x and y to the n power is equal to the product of x to the n power times y to the n power. Well, now we have three properties that we've discovered. Let's work on another one. Suppose we raise an exponential expression to another power. Well, the 3 outside applies to the parentheses, so it means 3 copies of whatever's in parentheses are multiplied together. That's x squared times x squared times x squared. 2 copies of x are in each parenthesis, and there are 3 copies of the parentheses in all. So there are 6 copies of x here, and the 6 comes from 3 groups of 2, a multiplication. That gives us the property, sometimes called the power rule, x to the n to the m is equal to x to the n times m. Here's a simplification that's going to require every property we've discovered. The numerator has 2 times a cubed times b to the 5th, all to the 4th power. So let's rewrite that. The 4 is applied to the 2, giving us 2 to the 4th. It's applied to the a expression, a cubed, and it's applied to the b expression, b 5th. Let's finish up with the numerator first. 2 to the 4th power is 16. A to the 3rd to the 4th power is a to the 3 times 4 power, and b to the 5th to the 4th power is b to the 5 times 4 power. That gives us 16 a to the 12, 3 times 4 is 12, b to the 20, 5 times 4 is 20. In the denominator we have a multiplication. 2a is multiplied by 4ab to the 3rd. Well, let's regroup putting the numbers together. We have 2 times 4, and the a's are a from the 2a and another a from the 4ab 3rd, and then finally we have a b 3rd. Well, if we simplify 2 times 4, we get 8. A times a is a squared, and b to the 3rd is still there. Well, now we'll divide. 16 divided by 8 is 2. A 12 divided by a squared is a 12 minus 2. And b 20 divided by b 3rd is b to the 20 minus 3 power. So finally, I have 2 a to the 10, b to the 17. These 4 properties of exponents are going to continue to be really important, so make sure you have them written down and you understand how to use them.